Alright, we're going to go through our Pythagorean Theorem guided notes. As you go through these notes, I need you to pause and fill in the blanks when needed, or re-watch so you can get all the blanks in. The Pythagorean Theorem is a formula used to find the missing leg or hypotenuse of a right triangle. The hypotenuse is the longest side of a right triangle. This side is always directly across from the right angle. The hypotenuse is represented by the letter C in the formula. A leg is the two shorter sides of a right triangle. They are the sides right next to the right angle. The legs are represented by letters A and B in the formula. It does not matter which leg is A and which leg is B. The Pythagorean formula is a squared plus b squared equals c squared. Using the Pythagorean theorem to find the leg of a missing hypotenuse. Find the length of a missing hypotenuse of a right triangle. We're going to write the formula. A squared plus b squared equals c squared. We're going to identify A, B, and C of the formula. Then we're going to plug in A, B, and C into the formula. We're going to multiply A by itself and B by itself, whatever those values are, and bring C squared down. Then we're going to add the two products together and bring your equal to C squared down. We're going to take the square root of both sides of your equation, because of opposite of squaring a number is taking the square root. And we're going to identify the hypotenuse of the right triangle. Don't forget to add the units. It will not be fully correct if you don't have your units. Alright, let's take a look at example 1. Alright, first thing we're going to do, a squared plus b squared equals c squared. This is your right angle. Your hypotenuse is always directly across from your right angle. You have a leg, and you have a leg. Remember, your legs are A and B, and your hypotenuse is C. We know A is 3, so we're plugging in 3 for 3 squared, plus B is 4, so we have 4 squared, and we don't know C, so we're going to keep that as C squared. Now we square each number. Remember, 3 squared is 3 times 3, which is 9. And 4 squared is 4 times 4, which is 16. And then we bring down our equals C squared. Then we add 9 plus 16, and we get 25 equals C squared. But I'm not done, because C is not by itself. And remember, this step is take the square root of both sides, because this number is squared, and we do opposites or inverses when we're solving equations. And we have to do this opposite to both sides, and the opposite of squaring a number is taking the square root. The square root of 25 is a perfect square, because 5 times 5 is 25. So we have 5 equals C. Since there's no units on it, it's going to be 5 units. Example 2. This is your hypotenuse. We have a leg, and we have our other leg. We write down our formula. A squared plus b squared equals c squared. It does not matter which is A and which is B. In our first example, it said A and B. I don't care if this is A or this is A, or this is B or this is B. It does not matter. we'll plug in 5 for A, 12 for B, and then we don't know C squared, so I'm going to keep it C squared. So 5 squared is 25. 12 squared, remember it's 12 times 12, not 12 times 2. 12 times 12 is 144, and I bring down my equals C squared. 144 plus 25 is 169, equals C squared. We have to take the square root of both sides. The square root of C squared is C. Square root of 169 is 13. So we put our answer as 13 inches. Part C, using the Pythagorean theorem, find the length of a missing leg of a right triangle. So the first thing we're going to do is write our formula, which is a squared plus b squared equals c squared. We're going to identify the a, the b, and the c of the formula. We're going to plug in the a, the b, and the c into the formula. We're going to multiply a by itself and c by itself and bring down our b squared. We're going to subtract that product from both sides of the equation and bring down the b squared. We're going to take the square root of both sides of your equation, because the opposite of squaring a number is taking the square root. And we're going to identify the leg of the right triangle. Don't forget to add your units. Alright, here, again, this is our hypotenuse, because it's directly across from my right angle. So that makes this side a leg and this side a leg. So the first thing we do is write down our formula. I always leave b squared by itself, but it doesn't matter which one you leave blank. So I'm going to plug in 12 squared for a. We don't know our other leg, so we keep it as b squared. And my hypotenuse is 13, so we have 13 squared. Twelve times 12 is 144. We don't know b squared, so I'm going to bring it down. And then 13 times 13 is 169. Now this time's a little bit different. We have to first get b squared all by itself. So we have to move 144 to the opposite side of our equal sign. So since this is positive 144, we subtract 144 from both sides, and I get b squared equals 25. Since we're squaring b, we have to take the square root of both sides. The square root of b squared is b, and the square root of 25 is 5. There's no actual units, so we just put 5 units is our missing leg. We're missing a unit here. We'll make that 10. Alright, again, this is our hypotenuse and our two legs. A squared plus b squared equals c squared. So I'm going to plug in my 10 for a squared. We don't know our other leg, so we're going to keep it as b squared. And our c squared is 13. Now we square our numbers. 10 squared is 100. We don't know b squared, so we're bringing it down. And 13 squared is 169. Next, we have to get b squared all by itself. So we need to move 100 to the other side of our equal sign, and we do that by inverse operations. So we're going to subtract 100 from both sides. That'll leave me with b squared equals 69. Now we have to take the square root of both sides to get b by itself. So we take the square root of b squared and the square root of 69. The square root of b squared is b. If we go to our calculator, 69 square root, we have 8.306. And let's round that to the hundredths place, so we look next door. If we look next door, the 6 is higher than 5, so that makes the 0 become a 1. And we have to add units to our answer.